All right, so we have our section 10 of the Alice Notes packet here, logarithms. Logarithms are used when you are trying to figure out what power to raise a base to reach a desired result. Logarithms are used to figure out what power to raise a base to get a desired result. For example, Alice is eating base 2 cake and wants to be 128 times her size. How much cake should she eat? So you're going to go to your pink sheet, your pink exponent sheet, and look at base 2. So that means we are on the row for base 2. So you're going to scan across until you get to 128. So in exponential form, it's going to say 2 to the what is 128. The logarithm form, we abbreviate the word logarithm to log, L-O-G. Log is in normal font. The base becomes a subscript. So you know how an exponent is little and up top? A subscript is little and below the regular font of log that we just wrote. So it's log base 2 of 128 equals x. So I need you to be really careful when you write this down, that you write log, the 2 is like next to the tail of the G and it's small, kind of like an exponent is small. And then 128 equals x. So again, in exponential form, it says 2 to the what equals 128. The logarithm form says log base 2 of 128 is x. And so on your pink sheet, you're looking for, again, on row 2, and you scan across until you get to 128, and we know that that would be the power of 7. So Alice would eat 7 ounces of base 2 cake to be 128 times as big. So a few more examples here together. Log base 2 of 64 means 2 to what power gives me 64? And so we want to write this whenever you see a problem in logarithm form like this, you would want to write it in what we would say is exponential form. So we'd write 2 to the x equals 64. So grab your pink sheet and get it close to if you don't have it yet. And I need you to practice looking at your pink sheet and finding that answer. And so again, base 2 will scan across that row and we'll see that x must be 6. Okay? The next example, log base 5 of 125 means 5 to what power gives me 125? And so again, we want to write that exponentially. So 5 to the what is 125. So now on your pink sheet, you look on the row 5. Everyone show me with your finger, scan across row 5 until you get to 125. And so we know that x equals what, everybody? Log base 3 of 81 means 3 to the what gives me 81. Write that on your paper. Write down what that would be exponentially. Good. Let's see if you got it right. 3 to the x is 81. And on that pink sheet, let me see your finger scan across your paper. Base 3, wrong paper. Grab your power paper. Base 3, 3 to the what is 81? Okay. Be sure that you understand how to use your pink power paper to get that answer. And go ahead and try the next 2 problems. I'll give you about 2 minutes to try them. Fill in the blanks and find the answer from your pink sheet. A little bit different problems here to think about.
Does that even exist?
All right, so this is a little bit different of an answer because we have log base 81 of 9. So it says 81 to the what gives me 9. Huh. So I'm looking for 81 to the something. My answer needs to be smaller. So I need you to think about how we were looking at fractional exponents last class period and how fractional exponents made the answer smaller. So you know that 9 squared is 81. So if we wrote this as 81 to the 1/2, remember that the denominator becomes the root, and the square root of 81 is 9. So my answer here is 1/2. If you are evaluating a problem using a logarithm, your exponent is missing, and your answer needs to be smaller, then you are going to use a fractional exponent. So remember that roots and fractions, they make numbers smaller. This next problem, the answer that we're kind of looking for is in the denominator. When in this unit, I need you to think to yourself, when in this unit did we shift things to the denominator? And so log base 3 of 143, let me say that again, log base 3 of 243 means 3 to what power is 1 over 243. And so on our pink sheet we can see pink sheet, we can see that 3 to something gives us 243, and that is 5, right? 3 to the 5th is 243, but we need the answer to shift to the denominator, and so right now this is 3 to the x over 1. If I really want that 3 to the x to go to the denominator, where the 243 is, my answer isn't going to be 5, but my answer is going to be -5. So there's 3 types of problems that you're going to have here. The first 3 examples were all nice answers, 6, 3, and 4, straightforward off of our pink sheet. The next example was where our answer was getting smaller, so our exponent had to be a fraction. And when we want our answer to go to the other side of the fraction bar, like going to the denominator, we needed to use a negative exponent so that cake turned into beverage. So in general, let's summarize this. In general, log base B, I'm going to go ahead and write this a little bit bigger. So log base B of y equals x. That is the same as b to the x equals y. So I want you to look and see how that would interchange. So earlier we were asking like 3 to the what is 243. We were missing that exponent. So the exponent here becomes where your x is, the base goes off the tail of your g, and the y is there. And so that's our general convention. So if I say on your worksheet, you guys are going to have the opportunity to practice things in logarithm form, writing it in exponential form, or I might give you an exponential form and ask you to write it in logarithm form. And we're going to be able to convert back and forth. So I have 10 examples for you. There's some space on the side of your notes that you can use right now. If you don't want to write right there next to the 3-hole punch area, you can take out a sheet of notebook paper, but there should be enough room there. So here's some examples. We have log base 2 of 128. It says to write in exponential form and then find the answer. So the x is missing, so that's the first thing. So you need to write down example number 1. Write down the example. Log base 2 of 128, write it equal to x.
Wow, they were picked up earlier. Cool.
And so we're going to write this as exponential, so it's going to be 2 to the what equals 128. You're going to scan across your pink sheet. You're looking at base 2, and 2 to the what is 128 off that pink sheet. Good. Next one, log base 3 of 243. Write down example number 2, log base 3, 243. Give you some time to write that down. Remember, the first step is to set that equal to x. So then on your paper, you're going to write 3 to the x equals 243. Scan across now row 3. Scan across row 3 until you see 243. And our answer is, okay. Example 3, log base 5 of 625. Again, set that equal to x. And so when we rewrite that in exponential form, we're going to get 5 to the x equals 625. And so now on your pink sheet, you'd be scanning across row 5, looking for 625. And we can see then that x needs to be 4. All right, so here's some specialty problems for us to look at. Log base 1/2 of 1/8 equal to x. Okay? So we're going to say 1/2 to the what is equal to 1/8. So just because it's a fraction doesn't mean that we need to freak out in any shape or form. But notice here I'm going from fraction to fraction. I'm not trying to move anything to one side of the denominator or another. I'm not trying to get smaller. And so I'm not going to actually have what you would maybe call a specialty answer. In other words here, I'm just looking for 2 to the what is 8. Because my numerators are both 1, I'm saying 2 to the what is 8. And going across row 2 on our paper, we can see that that answer is, yes, 3. The same on number 5. Go ahead and try number 5. You guys have about a minute. I'm going to set this equal to x, and I'm going to say 1/3 to the what is 1/81. So again, I'm going from fraction to fraction. 81's bigger than 3, so I'm just simply looking at my pink sheet and saying 3 to the what is 81. What are you getting here, this or this? This. Okay, and so 1/3 to the 4th is 1/81 because remember 1 to anything is just 1, and then 3 to the 4th is 81. All right, so a little bit of a special answer here though on number 6. Let's write this down. Log base 1/2 of 16. Log base 1/2 of 16. We're going to set that equal to x. We're going to set that equal to x, and we're going to say 1/2 to the what is 16. One half to the what is 16. So in this particular problem, we can see that 2 to something gives us 16. Okay, but we have the 2 in the denominator. So we need to pick the number off of our pink sheet, but we need to make that answer we need to move it to the numerator, so the exponent, this x that we're picking out, is going to have to be a negative. Okay, so 2 to the what is 16? 4. And so to say 1/2 to the what is 16 is going to be -4. So this 16 is 16 over 1. So to move the 2, so basically we're trying to move this 2 to the numerator. My answer is going to be negative 4 instead of just 4. All right, so that was all of the the specialty answers that we were talking about. Just a couple more so that you're prepared for your worksheet. These directions here are right as a logarithm. So to read this, we're going to say 2 to the what is 512. Okay, so we'll just do 2 of these examples here. Okay, so 2 to the what is 512. You're going to write on your paper log base 2. Okay, and it helps if you say log base because then you know what goes next to the g because you know what the base is. All right, so log base 2 of 512. And remember what you're trying to find is the exponent. Logarithms are helping you find the exponent so you know that the exponent needs to go on the other side of the equal sign. Okay? Log base 2 of 512 equals x. So the directions here do say then solve. Honestly, we would solve from the original format of the problem. So you'd go back to your pink sheet and find base 2. And we're looking for 512, and we know the answer then is 9. Okay? So one more time, how do we write this as a logarithm? We have 3 to the x equals 729. We're going to have log base 3 of 729 equals x. And so again, going back to that original format, is how we find our answer. 3 to the what is 729. So going to your pink sheet, going across the row number 3, and we see that x needs to be 6. Okay? So that concludes the examples here for section 10.